Let's go. Everyone fine? Very good, very good, very good. Yes. So let's go. Some people are not fine. Yeah. Summer or study. Hard work. This time climate is very hot this year. So don't move outside. Don't go outside. Heat waves are coming. Okay. Good afternoon. Let's go. Now, so in the last class, I think we have discussed about the ions and what is the reason, the formation of ions and all these things. Electron, proton, neutron counting also we know. So after we will melt like ice cream, sir. So that much delicate you are. You will melt. Be like a iron, strong, rigid, hard. Okay, now ignore. Come to the point. Melt like ice cream. Pagala. Now, listen very carefully, everyone. So this is the last class. So maximum whatever things I will try to explain, I will explain further in detailed discussion we will do in the class when you will come. So now after the discovery of electron, proton and neutron, scientist was curious to know what will be their arrangement inside the atom. Means if one atom they are observing, so inside the atom, in which place electrons are available and what they are doing there. That is the first question. Second question, inside the atom, what is the location of proton and neutron also? Means arrangement, or you can say overall, they was curious to know in which manner atom actually looks. Because normally you are not able to see the atom. But yes, by the experiment, by doing experiments or by your hypothesis, you can imagine by the behavior of the atom what will be the location of electron, proton and neutron. So in that thing, so many different models came, which are explaining actually atoms look like this. And in that, few are famous models. In those famous models, first one was Thomson model, J.J. Thomson, that Thomson person, same person. What he has said, the Thomson model. Now, so we are going to start Thomson atomic model. Thomson atomic model. So what was the Thomson atomic model and what Thomson was Thomson's hypothesis was there. So in the Thomson atomic model, Thomson said that atom is just like a sphere. If you know the sphere or watermelon, yes, very good. And okay, with a watermelon you can understand that watermelon is look like what? Sphere, spherical in the shape, not oval. Watermelon. Football, but football is hollow. Solid football assume in your mind. So you can say sphere. In that sphere or whatever solid part is there everywhere which is distributed, that he has said assume it is positively charged particle. So what Thomson said? Thomson said that atom is like sphere and positively charged particles. Who are the positively charged particle inside the atom? Protons. Protons are uniformly distributed everywhere. Uniformly distributed means if I am trying to draw the diagram here, so this is one sphere. It is look like circle, assume it is sphere. and everywhere uniformly what is distributed, so positive charge is distributed. Positive charge, this is positive charge. Positive charge, we all know who are the positive charge inside the atom, so we can say proton. We can say proton. So protons means positively charged particles are uniformly distributed, and negatively charged particle means electron, they are embedded, means fixed, trapped, you can say, inside that positive part randomly. So these 2 points was very important in the Thomson model. Ki there is a sphere, solid sphere. That solid sphere is nothing, just assume like it is what? Positive charge. And inside this solid thing, negative particles are embedded randomly. And yes, it is true, whatever total positive charge is there, same equal amount of negative charge is embedded. So overall atom is what? Neutral. So overall atom is what? Neutral. So overall atom is what? Neutral. But Thomson has no idea at that time when he has given this model about neutron. So about neutron he has not said anything. Actually this model came before the discovery of neutron. Before the discovery of neutron. So positive charge is there. This positive charge is uniformly distributed, and inside that positive charge, negative charge particles means electron is embedded randomly. Total positive charge, total negative charge, they are equal and opposite. So overall atom is neutral. So this model is actually look like watermelon. This appearance, this model appearance is similar to watermelon. Ki red part inside the watermelon, if you will observe, that is distributed everywhere, and seeds are embedded inside that, so that it has said ki this model, Thomson model, is nothing just what? Watermelon model. Watermelon model. Or it is also known as plum pudding model. Plum pudding is like one dish. You will search that about this dish in the Google. You will find ki there is a cake type something, and in that cake few parts are embedded, small things. So it is also known as plum pudding model. Plum pudding model. One more name to this model has given. One more name to this model has given. I think you don't know this name. Static model. What is the name? Static model. I repeat, one more name is there. If you know, it is very good. It is also known as static model. What is the reason to say static model? The reason is, in this model, no one is moving anywhere. No spin, no revolution, nothing is going on. Each and every people are situated in their own location and doing nothing. Means they all are in the static mode, stable mode, zero movement. So that to this model has one more name given. And what is that name? That name is static model. So now, Thomson atomic model, whatever was given, It has three names. First, watermelon model or plum pudding model, or you can say static model. Static model, the reason behind that, no positive part is moving anywhere and no any negative charge particles, whatever are there, they are moving. So overall, everyone is in the static mode. Static mode means static model. What is the benefit? Because this is totally wrong model. But it is explaining one thing very accurately. Anyone wants to say? What is the benefit? Stability, about electrons. This model at least, very simple thing, this model at least saying about the neutrality of the atom. Atom is neutral, it has also said neutral. It is not a very good point, but yes, neutrality, someone has written this side, neutrality. Yes. So only one benefit was there from this model. This model has said about the neutrality of atom. No any other extra information we have obtained. Totally false. Totally. And about neutron, they don't know. So neutron not present as per this model. So this model totally wrong. As well as, what will you say? Okay, very good. As well as this model is wrong, false model. The main reason further studies happen and it has obtained electron is not stable, or you can say not present in a static mode in its position. So this is the major problem. Yeah, very good. So this was a Thomson model. Okay. Worst model. Not good, but okay. Given. It has explained one thing only, that was the neutrality of the atom. Yes, atom is neutral. Okay. Then Rutherford came. Very good person and very fine person. Very smart. Rutherford. Which experiment he has done? Tell me. Rutherford experiment. Rutherford has done which experiment? Rutherford. Cold foil. He has done alpha particle scattering experiment. Very good. And that experiment, listen, Thomson has given model randomly by saying, by the visualization, no any research he has done. But when Rutherford came, Rutherford has done first his experiment. Rutherford has analyzed the atom, done proper analysis experimentally, and then he has given his own model, which was also not correct, but yes, it was good. It was good. He was not able to explain few points, but it was good. So what was the alpha scattering experiment? First, we will discuss about that, and it is very, very, very interesting. Alpha particle scattering experiment. Very interesting and very nice experiment. Because of this experiment, whatever conclusion came of this experiment, Rutherford has tried. He was near to successful also explain atom, but not 100% correct. But Bohr was much clever person. He has used all these information and then he has given Bohr model after that. Very good. So now observe. Rutherford has made one setup. What was that setup? He has taken one very thin gold foil. Very thin gold foil. And behind that gold foil, he has arranged one screen. One screen, ZNS screen, you can say. Zinc sulfide is applied inside that. I can say ZNS screen. And he has taken one device by which alpha particle was coming out. He has taken one here device. Just think this device is something from which what is coming out? Alpha particle. So here he has taken one device. With the help of that device, alpha particles are coming out. They are alpha particles. Alpha particles. And about 10,000 or more than 10,000 alpha particles he has just scattered on the surface of gold foil continuously. And what he has observed? What he has observed? Maximum alpha particle. Maximum alpha particle. Or you can say much more better manner if you want to understand. So just try to visualize by itself. Now see, he has scattered so many alpha particles, and what he has observed? He has observed so much shining or brightness came behind the gold foil, whatever screen was available. So much shining, more amount, in huge amount, shining came behind the gold foil. Few shining came this side, here and somewhere here. And here in the center, here in the center point, you can say very less shining came, as well as back side. Here also he has kept one device which has observed very little shining. Now this was the experiment. Experiment was this much. He has scattered so many number of alpha particles on the gold foil. Then he has observed maximum shining came behind the gold foil. Few this side, few this side, and very less if you will apply this side also gold foil, very less this side also. So okay, he has done some arrangement and he has identified like that. Ab now question is what? Think you are Rutherford. Think right now. Here and here, so much amount of shining came. What is its meaning? What is its sense? Maximum alpha particle moved straight. Moved straight. Because just behind shining came, its meaning is simple meaning. Simple meaning is what? Ki these alpha particles was moving like that. Whatever came in its path, penetrate it and move straight. Can I say like that or not? So maximum alpha particle moved straight. They moved straight. Not deviated anywhere, not returned back. They moved straight. Similarly, these alpha particles also move straight, and we know that these particles has penetration power also, so they moved straight. Okay, so that maximum moved straight, so maximum brightness came this side. This is the general sense. After that, whatever signing came here and here, that is a question mark, because no any alpha particle moving like this. So which particle is striked here? Common sense use karo. Use the common sense and tell me the answer. Which particle will go and hit here? Because in this manner no any alpha particle is going on. In this direction no any alpha particle is there. In this much area alpha particles you have sent. If any alpha particle hit this side, it means few alpha particle which should go straight, not went, they deviated and hit here. They deviated. 100% deviation happened. Without that, it is impossible to hit here. Same as it is, this should move forward side like this, but it is also deviated and hit here. So few alpha particles deviated, and out of 10,000, only one around like this, in this proportion, what happened? Out of around 10,000, one alpha particle just taken U-turn. U-turn means in which path it was going, in the same path it returned back. That was the observation. That was the observation of the Rutherford experiment. It is observation. After the observation, he has made few points. Ki maximum alpha particle moving straight, few alpha particles deviating from their path, and out of 10,000, only near to or only one or near to one is deflected, or you can say taken U-turn. Every 20,000, 10,000, okay, near in the huge number of alpha particle, one only. Somewhere 10,000 saying, somewhere 20,000, okay. Just observation is what? Ki in a huge amount of alpha particle, only one came or one taken U-turn. Just remember that. Okay. This was the experiment. That was the analysis of the experiment. Till this, Rutherford has now reached. Now from here, Rutherford has started to think why all these things happen. What is the logic? What is the reason? Because it is gold foil, so obviously inside that gold atoms are there. Gold atoms are present. And these gold atoms behave whatever is present here. So from here, about atom, some perception we can make. What is the first perception? The maximum part of the atom, I repeat, maximum part of the atom is vacant or hollow. No one is there. Because maximum alpha particles moved straight. No one was there to deviate them, to stop them, so that they move straight. Penetrate and go straight. Okay. This was the First observation. On the basis of these alpha particles came in the picture. Point number two. Point number two. Few alpha particles deviated, and very interesting. Why deviation happened? Yesterday we was discussed that when same charge particle come closer, they will deviate. Same charge particles will never attract to each other. Opposite charge particles attract. Positive repel, negative repel to each other. That we all know. Very good. Alpha particle, I have told you, alpha particle is nothing just equal to He plus 2 ion. What will you say? He plus 2 ion is equal to alpha particle. When anode ray experiment was going on, at that day I told you, if hydrogen gas you will fill inside the tube, you will get proton. And when you will fill helium gas, you will get alpha particles. So this is the alpha particle. Which kind of charge alpha particle has? So alpha particle has, sir, positive charge. It has positive charge, and positive charge. A common sense just use in your mind. These went straight. Means this side I can say positive charge was not available. But near to this point, assume in your mind that something is here like this. And it has some charge. We don't know. Positive or negative, I don't know. But when alpha particle came like that, if it is negative, so alpha particle should attract this side. If it is positive, so alpha particle should repel like that. And alpha particle actually repelled, means what we can say, whatever part was here, inside that 100% positive charge is available, because positive can repel to each other. And who has, or which particle has positive charge inside the atom? Proton. So Rutherford said the maximum part of the atom is hollow. First point. Point number two, inside the atom, somewhere, a very small place, in a very small volume, positive charge particles are there. Till this, we reached or not? Very good. After that, he said one more thing, very, very important. Whatever one taken U-turn, that is more interesting. Out of 10,000, 20,000, only one came return back. So what is the sense behind this? First sense, that positive part present in a very small volume, not huge. In a very small volume, means it is a very small area, or you can say volume, where that very small positive charge is there. First point this, and second point is more important than first. Think in your mind. What do you think? Yeah, think like that. Just think ki this is a small body, rat. Assume it is rat. Rat, do you know? Na? And this is elephant. This is elephant. This is rat. and they decided that today they will run and hit to each other. Okay, come. So they went in the ground, and then before the, you can say what, any race or something happen, one sound is going to build, and now after that, elephant ready, rat is also ready. Now they are coming to each other with their own speed, whatever they can achieve, and they hit. What will happen? What will happen? What will happen? Tata bye bye. Rat will come, hit, and rat RIP. They are maintaining that no one can die there. But now when rat will come and hit, rat will reverse bounce. Yes or no? Yes or no? Obviously, it is very heavy. And heavy thing will move this side. Means rat, elephant hit, rat reverse bounced, and elephant will hit and shift that backward side. It will happen. Okay. Now think here what happened. This is one body, an alpha particle is the another body. Both bodies are going to hit each other head to head. Head to head. If alpha particle is heavy, I repeat very carefully, listen. If alpha particles are so much heavy, no, it is okay that alpha particle is heavier than proton. Yes or no? Because proton mass is what? 1. Helium plus 2 ion means alpha particle mass is what? 4 times of proton. So obviously alpha particle is heavy. Yes. Alpha particle is heavier than proton. And when alpha particle came and hit to the proton, so same, now proton is in the rat position and alpha particle is the elephant. So ideally proton should reverse bounce or move back side and alpha particle should move still forward side. But it don't happened. It not happened. Alpha particle reverse bounce. It means the nucleus whatever are present in the nucleus what I don't want to use right now because nucleus at that time after this experiment nucleus word came. So whatever that volume is present here, small volume, whatever is here, it has positive charge. It was clear that few alpha particles deviated, but this part is heavy also. And it is heavy not only with the help of proton, some other particle is also situated there. That is the important point which you should understand. In that volume, that small volume, not only proton is available, it is a little more heavier. No doubt, some other particle is also available inside that, which further, when neutron discovered, then it has said that neutron was also inside that part. So he said, who? Rutherford, that volume which has positive charge and it is heavy also is known as a nucleus. Is known as what? Nucleus. So from here nucleus word came, ki there is an atom Inside the atom, somewhere small positive part is available. That part has positive charge as well as it is heavy also. Yeah, very good. And this is known as nucleus. And around the nucleus, negatively charged particles are present who are doing revolution around the, or you can say around the nucleus, whatever part is available, there negative charged particles are present. So this was the Rutherford experiment. Rutherford experiment has given some analysis first, and after that analysis, Rutherford has given its own model, which is known as Rutherford's atomic model. What was this? So what was this? So now, first point, he has said, now it's atomic model. It's atomic model. First point, atom has two parts, two region, two zone. First part he has said nuclear part, another part he has said extra nuclear part. So first he has said nuclear part, and second extra nuclear part. Who are available in the nuclear part? Positive charge, and it is heavy also, and this is actually known as nucleus. And in the extra nuclear part, who is available? Negative charge particle. Who are those negative charge particles? Electrons. What they are doing? They are doing revolution. Till this, Rutherford said. Now, as per the Rutherford hypothesis and his experiment, whatever he has done, and after that he has concluded that atom looks like, so he said atom is like nuclear part is available, and around that extra nuclear part is there, and who are available in the extra nuclear part? Electrons. In this manner. But problem was there. Rutherford was unable to explain its stability. When he has proposed his experiment result, means model, atomic model, so there was a scientist at that time, very famous scientist, Maxwell. He was very famous. Maxwell asked one question, because Maxwell has proved something at that time. He was also working on charged particle bodies, and then he has asked one question when Rutherford has given its model, कि Rutherford, when any charged particle revolve around another charged particle, it is one charged particle, it is another charged particle, when they revolve, when they, you can say this is the one charged particle and this is another charged particle, if one charged particle revolving around another charged particle, so this charged particle will lose its energy, means its energy will decrease, and there is no source who is providing energy to this particle to continue revolution. To continue revolution around this charged particle, just now here nucleus, here positive charge particle is available. It is electron which is revolving like that. So this particle will lose energy. Activity is happening. Your eyes are blinking, you are saying, you are eating, you are walking, you are doing any activity, energy loss happen. It is the natural thing. But that energy you are providing to your body by eating, and so many process happen, means glucose is going to burn inside your cell. Similarly, Maxwell said that no one is providing energy to this electron to revolve continuously, and still if it is moving, revolving, so it will lose its energy will go down, So if it is running in this much long circular path, big radius circular path, its radius will decrease. One common sense just use. Early in the morning, you just awake, and now I told you, go start running in your ground. 50 circles you have to complete, I have told you. So because just right now you are awake, you are very energetic, you will run in a big circle automatically. But after 10 circle, energy loss happen. And after saying this, I went out. I am not there. So what will you think? When your body energy loss happen, what will you do? It is the natural thing. I will reduce the circular path because I have to complete 50 circle. So first I am rounding in a big radius. Then I will automatically decrease my radius of the circular path because sir is not watching. Just complete 50 circle and move, because you are getting tired. Energy is going down. And after some time, your circle will become smaller, and then maybe you can be unconscious if energy will not remain in your body. Very less remain. So that Maxwell has said to Rutherford, now as per your model, when electron is revolving, so ideally electron should lose its energy, and its first circle was big, so another circle will be smaller, then next one more smaller, and one day all electrons whatever are present, one by one they will reduce their circular path, and slowly one by one they will come and merge with positive particle, and once negative and positive particle merged, atom identity will finish. Khatam. But it not happen. But practically in the real, it not happen. When it not happen, it means in your model, whatever Rutherford has given, there is a problem, not correct. It is incomplete. But at that time, Rutherford has no any answer of this question. So his model was kept like that. Okay, its answer not available, but yes, because he said experimentally after experiment all these things, so he was right in few manner, but he was not able to justify that. So this model not accepted that much. But yes, points whatever he has said, it was close, very close. Is it right? Because after that Bohr model also you know. So Bohr has also said similar type of things, and Bohr has cut that by saying something, cut that stability factor, because Bohr was also not able to explain the Maxwell point. But Bohr has said something ki assume, and because he said assume, so Maxwell point is going to cut there. Then Bohr we will discuss all these things are there. So in this manner Rutherford models was there. Bohr was clever, but he has done also so much work. His points was also correct in as per the knowledge or as per the equipment at that time was there. So much right things Bohr has said. But yes, there was a problem in the Bohr model also, so that right now the most acceptable model is quantum mechanical theory. And quantum mechanical theory is also not complete. So now you have an opportunity, you can go research and you can explain the model of atom. Okay, it is a different thing now, but you have selected to become a doctor, so become a doctor. That is much important. Very good, very good, very good, very good. So now these are the points. Now I think I told you to revise all these points, whatever we have discussed. So we have approx 10 to 15 minutes are there. So one by one, quickly, everyone will give response. We have started the discussion from the Dalton atomic theory. Dalton atomic theory, I have not told you points, but yes, Dalton has given his hypothesis. What was the Dalton's hypothesis? Tell me. Atoms cannot be possible to divide. But what happened? Some scientist came, like William Crookes was the first person. He observed that no, inside the atom something is also present. But William Crookes was very surprised. What was that? He was not able to identify it. And in this tension he went. Then who came after that? Plucker and Hittorf. They have done major studies. I am not saying that the physical, the properties of the cathode rays are only studied by them, but yes, majorly they two people has studied so much, and then those people studies plus Röntgen, other scientists, all the studies was added together, and then properties of, first they said that cathode ray is there. Cathode ray came in the picture first because of, you can say, Plucker and Hittorf, and that cathode ray formed with the help of which kind of particles, that studies are started after that. And then Thomson was the person who said first time that whatever cathode rays are there, which are coming from the cathode, originated from the cathode, moving towards anode, are formed with the help of negatively charged particles, and those negatively charged particles known as negatron. Who told? Thomson. Okay, very good. Then when they was doing study of the properties of the cathode ray, few properties came in the picture. Questions can come in the properties. Tell me quickly one by one. Cathode rays move in a straight path. In which manner they have identified? They kept one wooden block. That wooden block shadow came just behind that, same equal shape and size. It means they are moving in a straight path, because we know when light is going to strike us, and whatever light is coming from the sun, whatever light coming from the light source, they are also coming in a straight path, and we are getting shadow. So it has said that cathode rays also move in a straight path. Very good. Then they kept one metal block, low density metal block. Then cathode ray strikes, and in this strike temperature rays happen of that metal block. Means cathode ray can show what? Heating effect. And from here it was clear that cathode rays has energy also. Now, as well as much better clarification came that cathode rays has energy. That was happened by the light wheel pedal. When they have kept light wheel pedal, they have kept cathode ray strikes and light wheel pedal start to move. It means someone has given energy to the light wheel pedal. And who has given? Cathode rays, because inside the glass tube, who is there? Cathode rays, because glass tube was totally vacant. Vacuum was created at that time. So cathode rays hit only, so that it is going to revolve. It means cathode rays has kinetic energy, and kinetic energy means half mv square. Half mv square means velocity. Yes, I know velocity. Any moving body has velocity, as well as mass is also available. And from here it has said cathode rays has mass, or cathode rays are formed by which type of particle? They have a mass. Very good. After that, thin foil if you will keep, cathode rays has that much power, that much energy, they can penetrate it and move outside. As well as photographic plate if you will take, clicking photo, reel. reels, black color reels, or in the movies you will see one black color reel is earlier movies whatever are going on. So there is a photographic plate. If that photographic plate is coming in front of sunlight, in this chemical composition change happen. Similarly, whatever light can change the chemical composition of the photographic plate, cathode rays has also ability to change the chemical composition of photographic plate. Then we have studied if any gas we will filled, or yes, plates. Okay, then external electric field and magnetic field if you will apply, so your path of the cathode ray is going to what? Deviate, disturbed. They was moving in a straight path, but which side positive plate will be there, that side they move. It means cathode rays, by which particle they are formed, they have negative charge. Means cathode rays has mass, cathode rays has negative charge. And now these particles by which cathode rays was formed, Thomson said they are known as negatron. Very good. As well as when any gas is going to came in the path of cathode rays are going to strike and they are able to ionize it, convert them into ion. If hydrogen gas you have taken, so H plus ion will form, an electron will came out and that electron will move with the cathode ray. If helium gas you have kept, then He plus 2 ion will form. Whatever 2 electrons will come, that will move with the cathode ray. Means these gases are going to ionize when they are coming in the path of cathode ray. Means cathode rays has ability to ionize the gas particles also. All these studies was happen. Then mass, charge of the cathode, then Stoney, there is a scientist who has given name electron. Actually famous name is electron, not negatron. So now we are using electron word. Okay. Then charge of electron, Millikan has done oil drop experiment and he has given charge. That experiment is given in the NCERT. We will discuss when you will come in the class. As well as mass also given by the Thomson, and mass whatever he has given and practically whatever came, that is also nearly close. Okay. After that, when scientist has identified inside the atom, negatively charged particle is there and atom is a neutral, so it is a common sense inside that positive charged particle also available. And now everyone has started to do the discovery of proton, positive charged particle. To the discovery, when they have started to do positive discovery of positive charge, who has got the success in this path? Goldstein. And Goldstein has done which experiment? Anode ray experiment. What was the change on the setup? The change on the setup was there. Cathode they have taken perforated porous, or you can say canals was there, and this time gas is filled inside the tube, glass tube. Now what will happen? Cathode ray as usual in that high voltage, cathode ray again originated from the cathode and they started to move in a straight path and they are going to hit to the gas which is filled inside that. Gas will ionize. If I have taken hydrogen gas, I will get H plus ion. So many H plus ion. So cathode rays came, hit to the gases are going to ionize, and then cathode ray moved forward and given brightness behind the anode. Okay. Behind the anode brightness came means we said ki, okay, cathode rays came, but because that positive ions form, they will automatically start to attract towards cathode side, and cathode is porous. Canals are there. So from that pore, those positive ions pass and go and strike behind the cathode, and behind the cathode if they will strike, so behind the cathode this time what will come? Brightness will come. It means one more ray is available inside the tube right now, which is attracted towards which side? Cathode side. At that time, scientist has no idea from where it came, because they have taken cathode porous canals was there, so they thought it originated. From that canal, but it was not correct. Because of that, they have given first name canal ray. And also they was thinking ki maybe because it is coming from anode to cathode side, so they have given name anode ray also, but both concept was wrong. Actually, that rays was formed by the positive ions of the gas which you have filled. If you want to say anode ray is formed with the help of positive ion, which gas you should fill in, anode rays are formed with the help of proton, which gas you should fill? Very good, hydrogen. Then only you can say anode ray formed from the proton. If I want to say anode ray, I want to form with the help of alpha particle, which gas should I fill inside that? Helium. Very good, very good, very good. So anode rays behavior depend on the gas? Yes. Nature of gas you will change, anode rays types will change. But this thing happen with the cathode ray? No. Cathode ray is fixed. It will always form with the help of electron. So that cathode ray E by M ratio constant, anode ray E by M value is variable. And after that, so much studies happen, properties also. So many properties are same, few properties are different. First, direction of the movement, as well as second, they deviate and move towards negative plate side. Which side? Negative plate side. So in this manner, then mass of the proton, charge was the understood common sense type thing, ki how much positive charge is there, that much equal and opposite negative charge is there. So charge they consider same as it is, and practically whatever came, that is also same. So they was okay. But when they was happy, now they have identified all the particles, and then started to calculate the mass of atom. Like helium has 4 AMU atomic mass, and one proton has 1 AMU. Helium has 2 proton. So ideally helium mass should be 2 AMU. But came how much practically? 4 AMU. Again problem happened. Helium neutrality explained because 2 proton, 2 electron, helium atom neutral. But problem was mass. Then it has decided कि maybe one more particle is there which don't have charge, but it has mass near to proton, and practically it has came the concept of neutron. And who has find the success in this? Chadwick. Very good. Beryllium seed taken, alpha particle given, bombarded or scattered on its surface, and then one particle came which was neutral, but mass was quite higher than proton, little higher than proton. So now from here neutron came in the picture, and electron, proton, neutron has said or considered as fundamental particle of atom. Which atom? Fundamental, main basic particle. Other particles are also there, but main role of these particles are there, so that we are doing discussion in our syllabus also. Electron, proton and neutron is there only. Very good, very good, very good. After that, what happened? After that, atomic models are there. Ions, in which manner they form, all these things I have discussed with you. Okay, very good. As well as if anyone will come and ask you what is the good point in the Thomson atomic model, and which point Thomson, elephant and mouse, okay, after Thomson. In the Thomson atomic model, what was the right thing? Neutrality. Neutrality of the atom, he was able to explain. After that, everything was wrong. Whatever Thomson said, everything wrong except one thing, he has successfully explained neutrality of the atom. Neutron also was not discovered at that time. About neutron also he has not said, and he has given the model. It will similar to look like watermelon or plum pudding, so that it has also another name, watermelon model or plum pudding model, as well as it is also known as static model. That is a more important thing. They can ask a question, why static model name has given to the Thomson model? So you will say their movement of particle is not allowed. Electrons are available present in the static mode, as well as positive ions are also in the static mode. Everyone is in the static mode, so it is the static model. Okay. But it was totally wrong, not acceptable. Then Rutherford came. He has done alpha particle scattering experiment. In his experiment, he has observed maximum alpha particle move straight, means maximum part of the atom is what? Hollow. No one is there. Few of them is deviated, means alpha particle has positive charge, deviated, and obviously positive charge will deviate by the positive charge, means repel by the positive charge only. It means somewhere in the atom in a small volume, because few deviated, so he has said in a small volume what is present? Positive part is present. Because only 1 in 20,000 or 10,000, whatever given, you take an U-turn. It means that positive particle first point in a very small volume, means nucleus volume is very small than the atom volume. That was the conclusion behind that. Nucleus volume is very small in compared to atom volume. Atom volume is big, more, and nucleus volume is very small. Alpha particle hit, because alpha particle is lighter in this case, so that it taken U-turn. Means that, very good, that volume is heavy. Very small volume, but it is heavy. Means from here also one concept came. Neutron discovered so much late actually. Neutron was earlier not discovered. Electron, proton discovered in a continuous manner. About neutron, so much time actually taken. And in that main reason was there, it was neutral. If question will come, na, कि neutron discovered so much late. So what will you say? The main reason, or so many reasons are there. In that, one more important reason was there, that it was neutral. Sometimes in so many experiments, neutral formed. But problem was there, no one able to analyze it. Because any charged particle is there, so it will go towards positive plate side, or means positive charge, then positive charge particle, then it will move negative plate side and hit there. So we can identify, oh, someone came. Any negative charge particle is there, it will go and hit toward the positive plate side, and we can identify. Problem with the neutron, when it is formed also, it is not going to hit. It is moving straight. And ZNS screen will give you shining or brightness when charged particle will go and hit that. So it was very so many times, maybe before Chadwick, scientist has obtained a neutron, but they are not recognized it. That was the problem with the neutron. So that neutron discovery happened so much late. Okay. So in this manner, by this observation, you can say what? He has given his own model. Ki atom has two parts: nuclear part, extra nuclear part. Nuclear part is small and positive charge particle are there, as well as it is heavy also. An extra nuclear part who is available? Electrons who are revolving. But he was not able to explain the stability of the atom, so that it was not become so much famous. But yes, he has whatever said, not like Thomson. Thomson said anything. But Rutherford has said whatever by its experiment, by his experiment, whatever he has observed, that he has said. So it was right in a few aspects, but not able to explain his model properly. so that not so much highlighted. But yes, experiment till right now, there were so many experiments was happen at that time. We are doing study about the few experiments, means his experiments was considerable, so that is in our syllabus. Okay, so now I hope you have understand all these things. Do your best. Bye bye and be happy.